Hello, Hornets. In this video, we're going to be talking about a concept called the norm. Now, up to this point, we have said that our delta x was found by b minus a divided by n. But that requires that all of the delta x's start off equal and are equal. Even as they get smaller, all of the pieces are still the same size. But what the norm does is it also allows us to go to the same dimension for delta x, but only when it reaches infinity. See, the process is where you take the largest segment on a number line, which is what we're talking about, rectangles with segments, and we break that segment into two parts. And we continue breaking it up until it's no longer the largest part. So if I have A to B here, and I break it up, I might break it up like that. Looks like this part's a little bit larger. I'm now going to break it like that. That's now larger, still looks larger, no longer larger. And I now keep flipping back and forth. And at some point, I'm no longer going to be able to distinguish the larger parts and the smaller parts. They're all slowly becoming uniform. Not only that, but they're becoming normalized, uniformed, all the same. So as the delta goes to zero, as the norm starts to get smaller and smaller and smaller, our delta x starts to become equal. And this is something that's important for us because there's not going to be all of those times where we're going to be able to find our delta x equally. This breaks us away from that need. And we can now look at the integration as a function of the norm. The limit as the norm approaches zero, and we have a summation of I going from 1 to n of our f of c sub I, and I'm going to multiply by my delta x and back. And this is now what we refer to as our integration a to b f of x dx. So please be aware we're talking about the norms as we start moving into the future, where we have a uniformed delta x at infinity, where we have an infinite number of n values. All right. Thank you very much, Hornets. I hope this has given you some insight. We'll be using it next in the fundamental theorem of calculus. So thank you very much. Be well and be safe.